So here's a question. For number one, is that an nth term formula?
Yeah. No, isn't that a recurring?
This one's a recursive formula. This is what's called a recursive formula. And you recognize that by this relationship right here. A sub n and a sub n minus 1 are successive terms. This is the term in front of that one, which makes this a recursive formula. And in order to use a recursive formula, you have to know where to start, and it tells us to start with 12. So 12 is the first term, and according to this recursive formula, the next term, which is a sub n, is equal to the previous term plus 200. So if I want this next term, I go back to the previous term and add 200. So it would just be 212. And then the recursive just means you keep doing this over and over and over again, just adding 200 over and over. So 412, 612, whoops.
We just need the first 4 terms.
Yeah. So with recursive formulas, you aren't plugging in like n equals 1, n equals 2, n equals 3. You're just repeating a mathematical operation over and over again with recursive formulas. Question 2, the first part is just a yes or no. Is this arithmetic?
Yes.
And the way we determine that, you said yes because
There's a difference of 5.
Positive 5.
because we're adding 5 every time we go from one term to the next. So because we're adding the exact same thing every time, that's what arithmetic is. So the answer is yes, it's arithmetic. And if it says, if it is arithmetic, find the common difference. Well, we already found that, so d equals 5. The common difference was what we're adding every time. And then the last thing they want is the nth term. So you could either, if you want to remember the formula for the nth term is first term plus n minus 1 times d. You could either do it that way using a formula,
Or like the mx plus b.
or you could relate it to a linear function, like you said, and do mx plus b, where the slope m is the common difference. So it would be 5n. Well, it would be the term in front of the first. So if negative 7 is your first term, you would subtract 5 to get to your quote-unquote 0 term, which would be negative 12. So the nth term is 5n minus 12. And remember what I suggested? Anytime you create an nth term formula,
You test it.
check it, test it. According to this, our first term should be negative 7. If I plug in 1 for n, I get 5 minus 12, which is negative 7. My second term should be negative 2. So if I plug in a 2 for n, 5 times 2 is 10 minus 12, which is negative 2. Always check your nth term formula, make sure it's the right one. Yeah, so this one I'd do a lot different actually than the one we just did, because the one we did was geometric, and this one, like you said, is arithmetic. So what really helps is when you see arithmetic, you think linear. Arithmetic and linear are very much related, and linear means it's a line that has a slope, right? And so our first goal would be to find slope. And if you remember slope formula, slope is change in y over change in x, so it's the difference of y divided by the difference in x. And the way we talked about arithmetic sequences being related to linear functions was your x column could be your n column, and your y column could be your a sub n. And remember, n means what spot it's in the sequence. So this right here, a sub 10, means it's in the 10th spot. So I'm going to say that n equals 10. And the actual term there that's in that spot is 50. And then this next term here, a sub 40, means it's in the 40th spot. And the number that's in that 40th spot is 110. And all we need to find slope are 2 points on a line, and we have 2 points right here, so we just need to do the difference of y now divided by the difference in x. So the difference in y would be 110 minus 50. And the difference in x would be 40 minus 10. So then 110 minus 50, that's 60. And 40 minus 10 is 30. 60 divided by 30 is 2. So I've used the terminology slope, but slope is more related to a linear function. We need to use the terminology common for arithmetic sequences. A slope is the same thing as the common difference, because if you think about a slope of a linear line, that's the common change. And so with arithmetic sequences, the common difference is your slope. So this, rather than calling it slope, I'm going to say 2 is our common difference. And what significance is that? If I'm going from one term to the next term to the next term to the next term, what am I adding every time?
You're adding 2.
I'm adding 2 every time. So 2 is our common difference. Now the way that you build an nth term for an arithmetic sequence, or one way you can do it, again going back to this idea of it being a linear function, is thinking about mx plus b, where m is where our slope would go, but our slope is the same as the common difference, so a sub n would be 2n. For those that remember, what is b usually? In our world of linear functions, what is
It's
b?
usually the y-intercept.
It's usually the y-intercept, or it's where x equals 0, or our 0 term of an arithmetic sequence. We don't really have that, because all we have is the 10th term and the 40th term. But what we do have, so I'm just going to put a plus question mark, because I don't know what that b value is. But if I could plug something in for a sub n and also plug something in for n, then I could find this missing question mark. And I have one of those like right here. I've got an n value and an a sub n value right there that I could use in that equation. So if I plug in that 40 and 110, so a sub n would be 110 and my n would be 40. That could help me find that missing value there. So 2 times 40, that's 80. And if you subtract 80 from 110, you get 30. So now that I know the question mark term was 30, I could complete my nth term statement as a sub n equals 2n plus 30. And I can't tell you how valuable it's going to be on this exam if you choose to take it to check. So according to what we started with, what should the 10th term of this sequence be?
It should be 50.
So if we plug in a 10 for n, 10 times 2 is 20, 20 plus 30 is 50. So that one works for the 10th term. What should the 40th term should be 110. So if I plug in 40 for n, 40 times 2 is 80, 80 plus 30 is 110. So once you have an n term statement, always check it, make sure it's the right one. And it really didn't specifically ask for an nth term statement. It asked for the 52nd term. So why would we spend so much time finding an nth term?
Because now you to figure out what the 52nd term is.
By using the nth term. So now I could find the 52nd term by plugging in a 52 for n. So I could say a sub 52 is 2 times 52 plus 30. So 52 times 2 is 104.
134.
So it'd be 134. All right, for question 4. This is a partial sum of an arithmetic series. So you need to use the partial sum formula, which is n over 2 plus the sum of the first and last terms. N is the number of terms you're adding together, and that's 20. Then you need to know the first term and the last term. So the first term, if you plug in n equals 1, is 9 minus 4, so that's 5. The last term, if you plug in n equals 20, 9 times 20 is 180. 180 minus 4 is 176. So we have 10 times 5 plus 176. 176 plus 5 is 181. If you multiply that by 10, you get 1,810. Now question 5 is also a partial sum, so we can use the same formula. This time we know the first and last term already because it's written in the series. What we don't know is how many terms this is. All we see is a part of the series, not the whole series. So we know this is arithmetic, and it looks like the common difference is equal to 6. So we could find the nth term formula, which is 6n, and if there were a term here in front of the 0 term, or in front of the first term, or that 0 term there would be 9. So 6n plus 9 is the nth term formula. If I plug in 129 for a sub n, because that's this last term right here, then I could solve for n. If I subtract 9, I get 120 equals 6n. And then divide by 6, I get n equals 20. So there's 20 terms here. Divided by 2 is 10. 15 plus 129, that's 139, 144. And then 144 times 10 is 1,440.
Find the common ratio and the first 5 terms.
Okay. Key here is that this is geometric. So if you remember what each piece of the geometric nth term formula means, this number is your first term, and this number here is your common ratio. So just by looking at the formula, we could say that r equals 2. That's your common ratio. And then your first term there would be -4. Now, if you don't remember that, that's still okay, because to use an nth term formula to generate terms of a sequence, what number would you plug in for n to find your first term?
1.
N equals 1. So if you plug in an n equals 1 for n, you'd get 1 minus 1, which is 0. 2 to the 0 is 1, and 1 times -4 is -4. So your first term is going to be -4 regardless.
Wait. 2 times -4 is -4?
No, 2 to the 0 power is 1.
1, that's right.
And then 1 times -4 is -4. So we know our first term is -4, and the common ratio was 2. So we're just multiplying by 2 every time. So -4 times 2 is -8. -8 times 2 is -16. -32. -64. Does that make sense?
Yeah.
For question 7, common ratio implies that this is a geometric sequence. So we got to figure out what we're multiplying by to get from term to term. From 2 to 6, and then 6 to 18, and 18 to 54. Looks like we're multiplying by 3. So I would say the common ratio is 3. And since we know this is a geometric sequence, the nth term is exponential in form. So it's the first term times the common ratio, the power of n minus 1. So the first term there is 2. Common ratio was 3 to the power of n minus 1. So
A couple of them, but not every.
we've got some terms here that are not sequential. So we've got the second term and the fifth term. And the key here is knowing that this is a geometric. It's really important to know what kind of sequence it is. Because if it had said arithmetic, then you would be adding the same number d. But because it says geometric, you're multiplying by the same number r every time. And the reason that's key is if I put a blank for the first term because I don't know it, but I know the second term is 9. I don't know the third term, I don't know the fourth term, but I know the fifth term was 243. Knowing that this is geometric means that to go from the second term to the third term, I have to multiply by r. And then to go from the third term to the fourth term, I have to multiply by r again. And then to go from the fourth term to the fifth term, I have to multiply, because we're always multiplying by that same common ratio r. So to go from the second term to the fifth term, how many common ratios were there? There were 3. R times r times r means r cubed. So if you start with 9 and multiply that by r cubed, you should end up at 243 according to what we've written there. And then you divide by 9. Is that 27? And then you cube root. To get rid of the r cubed, you cube root and get r. So the common ratio is 3. And at this point, since we've done, a mathematical equation, it wouldn't be a bad idea to check. If you started with the second term and multiplied it by 3, then your third term would be 27. If you multiply that by 3, 27 times 3 is 81. If you multiply 81 by 3, you get 243. So that checks out. And then going the other way to get the first term, you divide by your common ratio. So the first term we know is 3. And we want to know that first term because in order to find the nth term, the formula for the nth term of a geometric sequence is first term times the common ratio to the power of n minus 1. So following that, we have our first term 3, and then our common ratio was also 3, and you raise it to a power of n minus 1.
Are they always going to be 3 terms apart?
Not always. If it was the second term to the fourth term, that's only 2 spots, so then it would be r squared.
Okay. But we're never going to have to plug in, I guess.
Is this going to be posted too?
I probably can. Yeah, if I can finish all the videos. It takes a little bit time to render it, but yeah. So you notice right off the bat, hopefully, that they're asking us to do an infinite sum, which isn't always possible. First of all, it has to be geometric, and it says it is. But even if that word geometric wasn't here, could you look at this formula and say, yep, that's a geometric sequence?
Yeah.
How would you know that?
The ratio is exponential.
Because it's exponential.
Yeah.
So in order for us to have an infinite sum, it's got to be geometric, and it is. But then the other thing is to know what r is. R has to be less than 1, which it is. So this infinite geometric series is possible to evaluate. And the formula, is S equals first term over 1 minus r. That's the formula for the sum of an infinite geometric series. And going back to the last one we did, if you remember how to read this formula, the number in the parenthesis, that's r, and that number there is your first term.
So I saw something online with these people talking about divergence and convergence with this. I wasn't quite sure.
Yeah, so those are 2 words that our textbook doesn't use, unfortunately. Other college algebra textbooks do. Converges means that the infinite series has a sum that converges to a single number. Like the ones we saw a couple days ago where it was 5.99 and then 5.999 and then 5.99. It's converging means getting closer to. So all of those are converging to what number? 5.99999 is converging to 6. So we would say it converges to 6. Whereas divergence means it grows apart. That's what diverging means. And if you have a geometric series where the common ratio is bigger than 1, then each term is getting bigger and bigger and bigger, so the sum is just growing and growing and growing exponentially. Thank you. That's what convergence and divergence means. So here we've got first term 4 over 1 minus the common ratio. So this is 4 over 3/4. And from here, I mean, this is totally fine to do on a calculator if you wanted. 4 divided by 3/4, or you could do 4 divided by 0.75. Or if you want to do this by hand, dividing by a fraction is the same as multiplying by the reciprocal. So it's 4 multiplied by 4/3. So it's 16/3. The sum would be 16/3. And if you did it on a calculator and gave me a decimal, that's fine.
It's like 5.3.
Yeah.
Really simple.
So expand completely, and it implies, since this is a binomial raised to a little bit higher power than just squaring, it implies we're going to have to use Pascal's triangle. So I'd start this by jotting down as many rows as you need of Pascal's triangle. The very top row isn't row 1. You remember what row that is? That's row 0. This is row 1. This is row 2. This is row 3. And since I'm raising it to the 4th power, I need one more row. So 1, 4, 6. So these would be the coefficients I need to use for this expansion.
Why is it a 6 in the middle?
So each number is the sum of the 2 above it, except for you always start with a 1 and you always end with a 1.
Okay.
But other than that, every number is the sum of the 2 numbers above it.
All right, that's fine.
So if this had been raised to the 5th power, we would need one more row for Pascal's triangle.
Yeah.
So that row would be 1, 5, 10, 10. You see how that works?
Mm-hmm.
Only need 4 rows because it's so far.
But we're only raising it to the 4th power, so we just need this 4th row. So those are my coefficients. Now, I suggested yesterday, no matter what's inside your parentheses for a binomial, I suggested you just think about an A and a B and do the expansion with A and B, just so you have a blank template that you can plug things into. So if it was A and B raised to the 4th power, your first term would have this coefficient, so it would be 1 times just A to the 4th. Your next term would use that as a coefficient, 4. And your A variable decreases to a power of 3. But then B, and we talked about this yesterday, if you add both of these powers together, 3 plus 1, you're going to get a 4. If you start with the first term, it has a power. So every term, they have to add to be a power of 4. So the next term is going to have 6 as a coefficient, and then A decreases to 2 and B increases to 2 because we want it to equal 4. 2 plus 2 is 4. The next term is going to have 4 as my coefficient. A decreases to the 1st power. B increases to the 3rd power. And then your final term has 1 as a coefficient. Technically, there still is an A variable, but it's A to the 0 power now. And A to the 0 power is just 1, which is why it doesn't show up. And then you have B to the 4th. So this would be the expansion for this binomial if it were A and B instead of 4y and 2. So all you need to do now is anywhere there's an A, you plug in a 4y. And anywhere there's a B, you plug in a 2. Does that make sense?
So would you...
Now, the most common mistake I see with following this as a pattern is students say, well, A needs to be raised to the 4th power. A is 2 or is 4y, so I'm just going to have 4y raised to the 4th power. And that's wrong. Because it needs to be the whole thing 4y raised to the fourth power. The big difference there, because now if it's 4y in parentheses raised to the fourth power, it's 4 to the fourth, which is 256. So that make sure that you, anytime you're making a substitution in here, you're doing it with a parenthesis. The next term is going to be the same coefficient 4, and then I'm going to put a in parentheses as 4y to the third power, and then times 2 to the first power, because b is 2.
Do you have to put the power sign, even though it's a 1?
No, but
If it's a
helps you.
1, no. I just want to make sure that I remember that these two have to add together always to be 4. The next term is going to have 6 as your coefficient, and again, always make your substitutions in parentheses. I'm going to put 4y in a parenthesis and raise that to the second power, and then I'm going to put 2 and raise that to the second power. The next term is going to be 4 as a coefficient, and then a is going to be 4y to the first power, and then b to the third means 2 to the third. And finally, 1 as a coefficient, you don't necessarily need to write that 1 as a coefficient, but b to the fourth power means 2 to the fourth.
And then we have to multiply it all out.
You just got to, multiply it all out. So 4y to the fourth is 4y times 4y times 4y times 4y. That's 256 y to the fourth. So make sure you follow order of operations. Exponents here have to come before you multiply any of the coefficients. So 4y to the third power is 64, y to the third. And then 64 times 2 is 112. And then 112 times 4. Let me do that one more time. We've got 4 to the third power there, that's 64.
To the third, y, third.
64 y to the third. And then I'm going to multiply that by 2. So 64 times 2 is 128. Yeah, 128 y cubed. And then 128 y cubed times 4 is 512. So this is going to be 512 y cubed. Now moving on to the next term, again, always do your exponents here. So 4y to the second power is 16y squared. And then 2 squared is 4. So it's 16 times 4, which is 64. And then 64 times 6, 384. So that would be 384y squared. 4y to the first power is just 4y. 2 cubed is 8. So 4y times 8 is 32y. And then 32y times 4 is 128. So this would be 128y.
Wait. 8 times 4?
8 times this, so the 2 cubed was the 8, and then 8 times 4 is 32, and then 32 times 4
Okay.
should be 128. And then the last one, 2 to the fourth power, is 16, and that would be your expansion.
Still not too bad.
Oh, that was so fun.
It was.